Good morning. My name is Manikant. I am from Aeronautical. Now I am going to say about a Poisson distribution. Poisson distribution is a limiting case of applying a binomial distribution. So this is what the Poisson distribution and the conditions uh, to be used. Are the places where the Poisson distribution is used. The Poisson random variable x defines the number of successes in an experiment. So x is the number of successes. To find the distribution of the via Poisson distribution. This distribution occurs when the events that doesn't occur on outcomes of definite number of outcomes. So generally the Poisson distribution is used in some conditions, some critical conditions such as the critical conditions means when n tends to infinity, the number of trials tends to infinity. And in another case, the probability of success where the success value, the p value tends to 0. So these are the two cases, and another case is the mean value, that is n and p is equal to 1. So in this case, since np is finite, the mean is finite in a Poisson distribution. In these cases, in the three following cases, we can use the Poisson distribution. So this is equation for Poisson distribution. This is an exact formula for a Poisson distribution, that is f of x is equal to e power of minus x lambda power of x by x factorial, where e is known as the base of a logarithm, the exponential value. It is equal to 2.77, and x is Poisson distribution variable. So Poisson random variable. It's a random variable, such as x is equal to number of heads in a tossing a coin, and lambda is average rate of value, that is a mean. So Poisson distribution, mean and variance. We conduct a Poisson experiment in which the average number of successes uh, within a given range is taken as lambda. In Poisson distribution, the mean of distribution is represented by lambda and e is a constant, which experimentally the e value is equal to 2.71828. Then the Poisson probability is given as p of x lambda is equal to e power of minus lambda lambda power of x by x factorial. In Poisson distribution, the mean is represented as expected x is equal to lambda x lambda. That is, it can also be said as NP from binomial basis. For a Poisson distribution, the mean and variance are equal. So this is one of the most important topic in the Poisson distribution. In the total Poisson distribution, in the total distributions, for finding the probability in only in the Poisson distribution, the mean value and the variance value are equal. So in the sense that it says that lambda is a variance of this distribution and lambda is the mean of its distribution. So coming from binomial distribution, we know that mean is equal to NP and variance is equal to NPQ. So in this, it says that Q is equal to 1. So in this, the failure is equal to 1. So in this Poisson distribution, it says that the failure is equal to 1. And what about the, probability of getting a correct one? Success is 0. So this is the finite cases in which we cannot deal this in an appropriate way, such as using random variables, binomial variables. Binomial distribution, random variable distribution. So this Poisson distribution is introduced for out. To manipulate the oppositions. The failures. So v of x is variance and e of x is mean, which is equal to lambda. Coming to this is a Poisson distribution table. So this table considers a value of the Poisson distribution, the probability of the case in terms of x and lambda. So since we have the formula, formula of Poisson distribution as f of x is equal to e power of minus lambda power of x by x factorial. Since p of x value, since p of x value is only dependent on lambda and the x value, and since e is constant, it doesn't depend on e, and it is a e is a constant value. So the Poisson distribution value, the distribution of the Poisson is dependent on lambda and x. So this table has one column as a lambda and rows as x. On matching this row and column, we will be getting the distribution value. For example, lambda value of 0.5 and x value of 0. This gives a probability of 0.6065. So this is a simple usage. This is a table. You can also use your mathematical tricks, for calculations. Substitute the values of lambda and x in the formula and you'll be getting the same value, but this is a table for Poisson distribution table. And thank you so much.